Hello and welcome back to Introduction to Cognitive Science. Okay, so last time we left off with we've sort of described a possible way that we can cast the human intellect as a physical symbol system, and this time we're going to talk about a way to challenge that using a major thought experiment called the Chinese room. So, like your thought, it's the idea that there's this low-level language at the heart of your thinking, right? It gives us this detailed account of how human minds are still physical, right? Physical symbol systems. Beliefs and desires are these sentences composed of actual, symbolic, like physical patterns of activation, but they are this sort of low-level symbolic system, right? And so these things will connect to reality by way of, like, their semantics have actual meaning for the world. So, person is drowning. Those are all concepts that have meaning, but you've derived from your experience. And ultimately, they can all be transformed using kind of the rules of language. You can construct new sentences, you can define new concepts, that kind of thing. So, remember that a major claim of physical symbol systems is that behavior is intelligent if and only if it manipulates symbols according to specific rules. So, based on this idea that the interplay of the semantics and syntax rules of the language, in the language of thought, ties the behaviors, like sort of the actions that we're going to take, to actual real-world meaning. It's not just this automatic process. The language of thought presents this idea that, this is an intelligent way of producing this kind of information. So it's not just knee-jerks and mallets, right? Or is it? So, enter John Searle. Searle suggests that the idea that simply moving symbols around, is that really sufficient for intelligence? Remember, two of the strong claims, sufficient and necessary means of intelligent action, right, in physical symbol systems. So Searle comes at this by proposing a thought experiment to more carefully examine how physical symbols manipulation in general could relate to intellect, or perhaps how it might not. So, let's talk about thought experiments for a second. These are useful tools for scientific theories or even philosophies to kind of examine the edge cases, right? What's the extreme? Take this to its logical extreme to figure out, like, is this actually viable? Sort of a stress test for a theory. So, the idea is you come up with far-fetched but technically possible scenarios to test the limits of a theory in question and see where it breaks. Does it actually break or not? So, the feral child from the last lecture is a good example because it's very extreme, right? How often does that actually happen? But it helps to illustrate the point, and it's not totally implausible because it's based on real world accounts. So, we don't need to actually have access to a feral child. We only need to know that these kinds of things happen and sort of what does under those circumstances. So, to take an even different, somewhat more extreme but alternative approach, here's what Searle proposed as a thought experiment to challenge the physical symbol system hypothesis. The Chinese room. Okay, so this is a thought experiment to examine what it means to be considered intelligent. So here's the basic question. Just because some system, a given system, can correctly move symbols around, does that mean that it genuinely understands the problem that it is solving? Is it actually genuinely intelligent? Now, genuinely intelligent is a squishy thought, but let's look. So, run forward to the future, where we live now. Do we think a calculator is intelligent? Right? It moves numbers around. Probably not. Right? We probably wouldn't call a calculator sitting on a desk an intelligent entity. It's not solving problems. It's not generating new things. It's just kind of a reaction. When I press a button, a symbol pops out. When I press these kinds of buttons, the correct symbol pops out, right? What about AI, right? Self-driving cars even. So there may be a way to argue both yes and no in these cases. AIs typically are doing complex things like navigating possibility spaces, right? They are using heuristics. They're cutting off options and picking only good things, right? A self-driving car is solving a lot of stuff simultaneously, and it's making what you could call judgment calls based on the current statistical data of the environment around it. So this discussion begins with Searle. So let's rewind. So the answer is that these things are not still yet solved, but they are still relevant in the modern era. So back to the Chinese room. So here is the scenario. There is a person in a room. Exciting. This person, so there is both an incoming slot and an outgoing slot for slips of paper. The slips of paper contain Chinese symbols. So far, this is just an input-output system, and it has some physical symbols. Okay, cool. We're kind of in the realm of a physical symbol system, right? We'll go ahead and draw what we've talked about so far. Here's a room. Here's a person. Here's an input slot and an output slot. And there are slips of paper with some kind of characters on them that we don't fully understand. Some of you who speak Chinese, of course, will understand, but I actually don't. These are just kind of random clips, so forgive me if it's like insulting or a curse word or something. Okay, so the Chinese room continues, right? The room also contains this huge instruction manual. The manual basically says, when you get this symbol, pump out that symbol. And, it's connecting the dots between inputs and outputs. Simple rules that can be followed based only on matching the incoming symbols with their rules in the manual. Okay, so now we add this pile of books with rules in them. If this symbol comes in, this symbol goes out. Cool. Okay, so this is an inefficient way to construct any kind of symbol manipulation system, but it's also possible. We haven't made any extraordinary claims here. We've just described a kind of silly, contrived, but possible scenario. So, a real person could easily be in this room waiting for slips of paper to look up symbols in the reference manual and put the right things out. Okay, so let's push this further. What if every input was a question and every output was an answer? We're kind of elaborating what the domain of each of these kinds of things are, the domain and range. So what if this person didn't speak a single word of Chinese as well? Okay. I certainly don't. So if the manual is robust, it could emulate, to a very high degree, a native Chinese speaker in every meaningful way. It would be slow. The person would have to thumb through the index and figure out where the correct answers live, but they would be able to do it, right? It's not unreasonable. So back to our Chinese room, right? So a question comes in. The person looks it up among this stack of many varied books and possibilities, and then they output a correct answer. Not even just correct, but say a useful answer, something that is reasonable, that a human might say. Okay, so let's look at the Chinese room. It's a great example of a physical symbol system. The symbols are the basic things that are coming in. They might not be, I guess the individual symbols might compose sentences if they are full questions, right, and full answers. So we've satisfied a couple of the constraints. The syntax is how the symbols and they work together preserves the semantics of this whole thing, right? All of the incoming sentences are properly generating, all the questions that come in have reasonable answers that can go out. Here is the trick. does this physical symbol system understand Chinese? It's not a clear answer. You could kind of see it going a few ways, right? Searle says there's no understanding happening here. The Chinese room symbol system maintains excellent semantics and syntax. It's doing all the things. It's solving the language. It's doing, you might even say it's correctly like handling things in a way that would be similar to a language of thought. But how can this system understand Chinese when the person inside it can't understand Chinese? Searle held this as a strong counterexample to the idea that physical symbol systems are sufficient for intelligence. But how fair is this claim? To evaluate that, let's take a sidestep into the Turing test. So, have you heard of the Turing test? Many of you have. And it almost nothing to do with our friend the Turing machine. They just have the same dad. So, the Turing test, the imitation game. It's not as dramatic as the film, but it's a pretty simple test. And it's designed to say, is an artificial system sufficiently confusable with a human such that they guess at chance if they were forced to choose? So let's kind of pull that apart. There's a person, and there is, on one side of a wall is a robot, and the other side is a human. And I say robot, I mean an AI algorithm. Think of Eliza if you want, right? And there's a wall. They can't tell who's who. And each one of these is mapped to a computer, right? And you can interact with either one of them. You talk to each of them, and then you tell me which one you think is the human. The Turing test, an artificial agent, an artificial system is said to pass the Turing test provided that it becomes indistinguishable from the human. It's Cleverbot, for example. What do you think of the Chinese room argument? I don't know what that is. You haven't heard of it? No, tell me. It has to do with you and how you work. That's not the same thing. Do you think you're intelligent? No, not really, do you? Yeah, no, I agree. That's just a fun example of chatting with the Cleverbot website app. But the idea is, this is kind of showing both sides of the Turing test. You can see that this is almost confusable with a person, but it's perhaps not quite. Whatever side you fall on, of whether you would mark this as confusable with a human or not, doesn't matter. The Turing test is just a basic indication that a machine could potentially be intelligent. If it's confusable with a person, that's a good sign. And it's very compatible with physical symbol systems because it's moving symbols around, right? But so Searle would come at this angle using the Chinese room and suggest that absolutely fine, the Chinese room will pass the Turing test. It will be confusable with a human. That's kind of the point. It's expressly designed to replicate a native Chinese speaker's inputs and outputs, right? So this highlights that, the Turing test is just a confusability index. It's not a deep investigation of intelligence. That's kind of why I've brought it in here. It helps to illustrate that the Chinese room, as an example, is something that would perhaps pass the Turing test, but not necessarily be intelligent, according to Searle. So, back to the conundrum, that particular conundrum of, is the Chinese room intelligent? So, the Chinese room is a pretty good thought experiment. It provokes the right kinds of questions. The Turing test kind of illustrates how the Chinese room could be seen, at least as possessing the capacity of being intelligent. But there are other elements that we can kind of focus on to figure out how we might reply to Searle. And these are actually well-known replies. You get to learn some argumentative replies here. So this is sort of how academic debate and discussion can occur. So there are two replies. We'll start with the systems reply. So Searle focuses almost exclusively on the individual person. So his point is that the person doesn't understand Chinese, how could any intelligent action actually be happening here? And the systems reply says, well, hey, by your own definition of this system, the person is just a subcomponent of the entire system, right? So from a systems perspective, why can't we say that the Chinese room understands Chinese, not just the individual human who is operating it? So in the same way, Searle might say, oh, well, because your brain contains the rules of English and you take inputs, process them through it, and produce outputs, you don't understand English. This is pretty solid, I think, right? This is a way of saying, hey, interconnected, complicated systems have this property called emergence, where things will happen among them, right? As the interactions between them occur. Now, this does leave a bit of a hole, because is intelligent behavior the same as it possessing intelligence? So is just memorizing a full list of appropriate responses to inputs, is that actually good? Is there actually an intelligent process behind that, or is it just a single one-to-one mapping of all the right things, saying all the right things, right? Without having an actual process going on inside. So, Searle's reply to the system's reply itself is, if you memorize the entire manual, you're actually missing a key component of intelligent action, which is generalization, right? If an input comes in that is not in the manual, there's no mechanisms hiding that can help you generate an appropriate response. It's just, it errors out, right? There's no option, there's no proper reaction. It's just, oops, I don't know what the output is to that answer, to that question, rather. So where is the genuine understanding? Compelling reply. I think the system's reply itself and Searle's response to it are both kind of good points, and that's why this has been a hallmark of the debate on this question for some time. So, in general, the system's reply. Okay, so Searle's complaint is touching on the idea that we're more than just pattern regurgitators, right? We can use a variety of abstract processes, things that we might label as creativity, insight, that kind of stuff, that the Chinese room system would not be capable of doing because of the way it works, right? The human has no way to move, to properly recombine rules to create new ones or to generate a response in lieu of a known answer. So the person in the room, the only likely source of any creativity or insight, they don't understand the manual. Okay, cool. So this isn't to say that the system's reply is fully dismissed. This is just to say that the discussion had some genuine back and forth. The robot reply, on the other hand, kind of continues with the thread. So the robot reply suggests that sure, the Chinese room does not understand Chinese, but not because of not for the reasons that Searle is presenting. The robot reply says the Chinese room doesn't understand Chinese because it's not embodied. It's just this slab. It's just this room sitting doing nothing. It's a brain in a jar, right? Embodied agents, like humans, are the ones that actually interact with the world, not just trade on slips of paper, right? We kind of touched on this with the semantics of the language of thought, right? The semantics of the language of thought are the idea that the concepts that you build actually interface with your experience of the real world. So if the Chinese room could experience the real world, it might be able to understand the way its symbols interact. So semantics arise from meaning in the world. So suppose these are some goals of intelligent behavior involving the language Chinese, right? You need to be able to carry out certain instructions, right? You need to be able to coordinate with others using the symbols of the language, right? You need to be able to read the language and incorporate that into your knowledge base. And you need to be able to have a conversation using the symbols, right? So you need to be able to do things based on symbols, exchange symbols, use symbols to align your actions with others, and to trade symbols, right? All these things are the way that we interact in an embodied way in the environment. So, to achieve those goals, we'd have to add some things to the Chinese room. They would need some way to sense the world around them, right? They would need some ways to move and interact in the world. So, some kind of motor system, some legs, maybe some tank treads, whatever the heck we want to give it. It needs some way to move, right? It needs some way to take in vision from the world, and it needs some way to speak, to actually interact with others, not just through slips of paper, right? So a more live way. So let's say we give all that to a robot, like a really well-constructed robot, right? Ramp it all the way up to Android, right? Why would we claim that the robot, this fully embodied agent in the world, doesn't understand Chinese, right? It's able to act, it's able to converse, it's able to read, it's able to do all the things that we would expect of an intelligent agent, and it's doing them all in the world. Now, Searle's reply, of course, he's not convinced. He stands by his theory. Although, some people will hang on to a theory until they're dead. Pick the hill to die on. So, not to say that Searle was without merit, his arguments are without merit, but the point is that he is not convinced. Pardon me. Understanding, he says, is still not necessarily implied by learning to do the correct things. It's sort of the same core argument that he had before. It doesn't matter how complex the situation is, it still doesn't imply the understanding that he's looking for, right? So he's not really down with the embodiment concept, which we'll touch on in the future. But this is, to a lot of people, this is kind of a far reach. So can humans actually clear this bar? If Searle is unconvinced by something that moves, acts, talks, behaves, and does all the things it should, it's able to move information in and out, it's able to process it properly, and it's able to adapt and use it, could we clear this bar? What exactly do we need to do to show that we are above and beyond the embodied Chinese room, above and beyond that we are intelligent? So, this all kind of spirals us down into a kind of a core problem for the field of cognitive science, at least in some circles. So, Searle's Chinese room gives this good discussion of this idea of like, hey, what does it actually mean to be intelligent? How are we, connecting to the world around us? Where is the genuine understanding of the world? But it also highlights and creates, sort of poses this fairly difficult problem. If the language of thought, for example, relies on this good syntax and good semantics, there ends up with this kind of fuzzy question of how exactly are symbols connected to the real world? How does a symbol, any symbol, become meaningful? We talked about the child, right? The child who is the feral child. They have these sort of meaningful symbolic thoughts. They have these symbolic concepts that have meaning in the world. Boars eat berries. I want the berries. Boars have the berries. That kind of thing, right? But how did those symbols come to be? And how do we tie them to things? How do we bridge this gap? Because abstract symbols, these weird patterns that are internal to the mind, or perhaps specific to language, in Chinese room example, and actual real-world meaning. How the heck do we get there? It seems simple. You repeat "da-da, da-da," right, to show a child who its father is, right? But how does that become the abstract, movable, robust concept of father tying to that language symbol? I'm not going to be able to tell you. This is a standing issue, right? So symbol grounding in general. Let's kind of cover it more clearly. So when you're learning a language, we will bundle up meanings of other words into words, right? The definition of cat is something like four-legged feline animal, mammal, right? That has whiskers and ears or something. But all those words are just other words, right? And so what is the first word? How did our first words become tied directly to our thoughts? Another thought is you learn the name red, thankfully, and it ties directly to this sensation in the world. But where is the boundary? This is a tough question. I'm meaning primarily only to get you to think about it, right? We're not going to solve it today. But the question is, how deep does the rabbit hole go? How do we acquire meaning for all of these things? Maybe it makes sense to you right out the gate. Maybe you need to write a thesis on it, right? But more importantly is that it's an interesting gap between abstract and concrete that is posed by this Chinese room thought experiment. So, to sum up what we've talked about here, so information processing in general is this useful method for understanding a lot of cognition, right? It's this overarching theory for how minds work. We're moving symbols around. There is this downward spiral into the grounding problem of how, okay, if information and symbols is how the mind works, like the physical symbol system hypothesis says, we might use something like the language of thought to move symbolic information around and create an understanding of the world that is meaningful. We do wind up with this gap of how do the symbols live above the real world, right? So there are two ways forward. We can explore the non-symbolic forms of information processing, sort of the more of the connectionist things, the neural network type things, which we will do, or just abandon information processing entirely. Searle certainly says so, but more. Now that doesn't mean we stop thinking of the mind as being able to handle information, but we stop casting the questions of cognitive science in terms of these precise ways that information is moved and processed, and more focus on, say, distributed systems and dynamical systems, the ways that different multiple moving agents all connect together. Big math stuff. So we'll do both, but we will start more in the realm of the former than the latter, and we'll move on forward. So, final thought. Which argument do you find most compelling? Are Searle's responses satisfying to you? All the possibilities are valid, but think about which one aligns most with what you think. All right, that's it. Thanks. Take care.